49 over 4. Minus 7 times 7, 49 halves, plus 12. If you go this way, we need to get a common denominator. So, here we go, shift from side to side. We know we do this. So that's 49 fourths. How do you turn that denominator into a 2? Times 2 over 2 box game. 98 fourths. How do you get a fourth down there? Times by 4 over 4. Good job. 48 fourths. You know we're trying to make this easy. What's 49 plus 48? 97 minus 98. That's negative a quarter. So if you go this way with improper fractions, the y-coordinate of the vertex is negative a quarter. So it's right about there. And then we need to label the vertex. 3.5, comma negative a quarter. That's okay. Now before you take off with symmetry, who's the next guy you plot?
The y.
Good. And how much is it? All right. And you make it work up here, and you label it. You don't have to worry too much about scale. Great point. 3.5 units. 3.5 units to symmetry. We're just sketching this right now. Are we okay? All right. Constant curvature. Do the best you can. You don't have to be perfect, but that's that's good enough. Y-intercept is 12. X-intercepts, those are zeros. That's the vertex. You don't have to have the symmetry, but we know it sure does help to draw it symmetrically. Everybody okay? Pretty basic one. The only thing a little bit hard about that was dealing with the improper fraction, and you know that we can also do a decimal with the calculator. The next one is a little bit more fun. I'm going to need to take this out. Take this out. And let's go do the next one. All right. 5 is a negative x squared. The negative is going to make it open, Kevin, open. Right. You know we've done these before, and you know that we pulled an egg out. What's it going to become when you do that? Okay, when you set it equal to 0, you can get your zeros now. And before we've done this algebraically, we have divided each side by -1. And when you do that, what happens to the neg? It's gone. You kill it, right? We've asked you not to do that here because the neg is going to make sure the parabola opens and you won't miss it if it's still there. So leave it there and go factor this equation. It's a minus minus, so we know that's going to be a minus plus. It's a 2 and a 1. And who is the winner? It's a -1, so what sign goes here? If you make it a plus 2 and make that a -1, are you going to get 2x minus x? That's a plus x. So we change those signs. Do it this way. And so now if you're careful about this, and you remember we want to check this, your inside becomes a what? And what's the outside? And what's minus 2x plus x? Negative x, and that has to match. It does. So give ourselves a little room here. Does the negative come down here and affect our intercepts? No, it just stays out front. It's going to open it down. So go to get your values. You get -1, and you get 2. Beautiful. Well, let's take a look at this one. We know to come over here and sketch it. So -1, label it. 2, label it. What's the middle value? Well, by eyeball, it's about there, but we need the value of it.
1.5.
Is it 1.5? What is it? 0.5. Let's find out. We can always add them up and divide by 2. So b sub x is 2 minus 1 over 2. That's a half. The other way you can check this, you guys, is use it as a number line. How far is it from a half to 2? 1.5. And how far is it from a half all the way to -1? And it should be equidistant, right? It's the middle value. It's symmetrical. Now you got yourself another cute little fraction. It's a half. Now be careful when you substitute that back in. You're going to get -1/2 squared plus 1/2 plus 2. All right. What's a half squared? A fourth with a neg in front. So neg a quarter plus a half plus 2.
So 2 1/4.
Good. It depends on how you did that. Terrence, did you go 2 plus a half first?
Yeah,
maybe?
and then, yeah.
Good idea. 2 1/2 minus a quarter. 2 1/4. There's a lovely little fraction. That gave us the y value of the vertex. So you're at a half. Interestingly, 2 1/4 is like somewhere up here. Why does that vertex need to be up there? How come? Because it opens down. And we can confirm that by our next data point, which is the...
Y-intercept.
And Risa, what is that y-intercept? It's 2. And so does this begin to make some sense?
Yeah.
And we can use symmetry over here as well. And you know what? You got it. And I missed that terribly on the right. That's close, E. Vertex is a half, comma, 2 1/4, x-intercept, y-intercept. Why is that one a little bit trickier? Well, it's a negative in front. We ask you to keep it so that you know the behavior opens down. The rest of it's not too bad except the fraction. So those are the two that you guys asked for on the learning side. Is that all right? Okay, let's move on to today. We don't need this. We're going to do that, and I want to show you something first. Okay. First thing we're going to do is consider our foundation graph. And the foundation graph is y equals x squared. Because what we're studying today, read it out loud.
Transformation.
If I can fit it in. Transformation. When you transform something, what do you do to it? You move it, change it. Maybe it's its shape. Transformers. Anybody got transformers? Those bot guys or whatever? Yeah, it's the same thing in mathematics. We're going to transform, move, change shape kind of thing. The key is you're going to be comparing it and transforming from the base parabola y equals x squared. So we want to keep that image in our mind as we go through and do this. Let's go do the t-chart. We'll just do it from -2 up to 2. Ready? And we're plugging it into this equation. So -2 squared gives you...
4.
All right.
Is it perfect square?
It's a perfect square. So what's -1 squared? -1 squared. 1. You should start seeing something here. What's 0 squared?
0.
Origin. Should we see symmetry here, maybe? What's 1 squared? What's 2 squared? And we can do another one. By the way, what's -3 squared?
9.
Heck yeah, it's up there. What's 3 squared? Do you have a nice little parabola? Yeah. He's a little off, thank you. He's a little off. Let's go fix him. Thank you. That one's okay. And so draw your curvature. That's close enough. I'll sort of fudge that one in a little bit. Okay? That's okay for sketching. That's y equals x squared. Right, June? Okay. This is the one I want you to keep it in your mind because we're going to play with him. We're going to shift it left and right. We're going to flip it. It's going to go up and down. And one of them is hard to understand today. We're going to talk about this. One thing today is a little hard to understand. So if you have that image in your mind, I want to open up the gizmo because that's the guy that's going to really help us out. Okay? Everybody cool with that? Y equals x squared. Okay. Get ready for something a little bit hard to understand. My gizmo is still alive. I believe it is. Okay. Something new. And I had the title up here if you want to see the title. It's on your gizmo. We'll have you open up your Macs in just a second, but I want to get you started here first. What does this say right here?
It's in the vertex.
In what form?
Vertex.
Huh. Once upon a time, you knew an equation like this. What's it called?
Slope intercepts.
Pretty good memories. Slope, intercept, 4. It's just a form of a linear equation. What's this guy do for you?
The y-intercept.
The slope, that's the...
Minor slope.
Okay, it's just a form of linear equations, and we learned 3 of them, of course. Here's another form for you having to do with quadratics. You're going to use this in a lot of analysis too. It's a little bit weird because it's got this HK thing in here. Those of you doing geometry enrichment have already seen HK as a center of like a circle. If you've done the circle unit yet, we'll talk about that. So HK is a kind of default XY coordinate pair for certain functions like circles in this case, forever. The reason that we study this guy is that that form, who can you read right out of it? The vertex. There's a thing called complete the square that we'll study shortly that will show you how to get this form. Because you guys have been studying this one pretty much all along. The base quadratic equation of like a trinomial. You haven't seen this one until today, right? Okay. So what happens here is we're going to study it because of this relationship here in mathematics, that the vertex is actually h comma k. So just kind of like assume that's true for now, the way this is going to work. Life's getting ready to get interesting. Okay. You ever seen that before? Now we know him. He's our default parabola. Does this look about right to you? What's the vertex of this guy? 0, 0. You put in 1 squared, you get 1, 2 squared, 4. It looks pretty good. Okay. So, here we go into uncharted territory. Let's try to make this make sense. If I ask you to consider, I'll even put this up here because of the plus 0. Okay, it's kind of weird. Consider this. This is y equals x squared, right? Yeah? What happens, and what's the difference between this parabola and this one? Can you describe what it will graph as? What's different about it? Ideas, Terry.
It has a plus 4.
Good point. If you were to perfect square this, what do you guys get when you actually multiply it out? You get x squared? You're going to get a plus 4, but what's the middle term? Y'all remember that? When you put it side by side? Minus 2 is going to give you what? Minus 4x, and the last term is going to be? Right, and that's true. If you perfect square x minus 2, right? X squared minus 4x, well, that's true. I don't know if that helps you a lot right now understand what's going on and what I've asked you to consider relative to, he's getting a little bit weird, relative to what the transformation is. One more time. And I know this is the first time I've asked you this and it's a little weird, I told you that. What is the difference between that parabola and this one? A little bit of help. If you set that at Kelly, ideas.
It would move forward
4 units in the
Right, Kelly's suggestion is it's going to shift to the,
4 units.
well, let her finish. It's going to shift
to the right.
to the right. We'll come back to that. Wayne.
I think it will shift for next
All right, this is the confusion. Is it going to shift to the right or is it going to shift to the left? And I've got like 3 ways to explain it. I'm not sure which one's perfect. It all depends on your learning style. I will tell you that one of the 2 is right here. It's either right or left. Okay? And the problem is, how do we know? A little bit of advice. When you guys had equations like this equal to 0, how did you solve for the x-intercept? Isn't it x minus 2, x minus 2?
Yeah.
So didn't you go use zero product property? And you got what? 2, and it became a double root. Remember we talked about that? Quadratics all have how many roots? 2, but you can get a double root, right? And I just showed you how to solve that. You know how to solve that. So one more time. Which way does the parabola shift from here? Does it shift right or does it shift left?
It doesn't shift.
Yeah, it does.
Right.
Yeah, it does. Which way to go, guys?
Right.
Why does it go right? Joe, I'm going to come back to, who did I skip over here? I skipped somebody. Joe, go.
Can I take that?
Yeah.
Okay, is it?
You want to show it?
No.
No, okay.
Is it because the number's positive?
Yes.
Oh,
And the root becomes positive 2, right? We know how to do this. The thing that's really strange is, Mr. Green, you've put a 2 value in for that h, and I've covered it up. Let's uncover it for a second so we can see it. Smartboard is getting a little bit tired. You've put a 2 in for the h, correct? And it's x minus 2. And the thing that's strange about this is you guys are very familiar with number lines. When you go negative, don't you go left?
Yeah.
So when you put in minus 2, why does it go right? Because, a couple reasons. One is you just proved it. Benji, go ahead.
Because the h itself is negative.
Bingo. That's one really good insight. The h itself is actually a negative because how do you turn, well, if you go negative h, what value is in here? Let me say that one more time. You're talking about the h being negative 2, and so a neg 2 becomes a
Positive.
That's one way to look at it. That's a little confusing. Okay? The simpler solution, Risa, go ahead.
What about the exponent? Is it like -2?
The exponent is just going to make it a quadratic. It's going to make it a parabola. The thing about our shift, though, is that, do you all see the connection here between x, y, and hk? See that? Chord pair. So one of the reasons is it shifts right because of the zeros. And you all have proven that. It's x equals 2. We know that's true. What a lot of times high school students will do is they've seen this, they understand it, now they just want to go fast. So they take the opposite side. Because if you set it equal to 0, it's going to become a 2. You take the opposite side, it shifts right too. That's what high school kids will typically do. They just want to get it right, they want to go fast. So this is the hard part about today. The hard part about today is an x minus is actually a right shift because of what we just talked about.
That's what x.
Excellent.
If the h is a negative, and then the -2 is the h, then shouldn't you have written x plus 2?
If the h were truly negative, yes. But Benji's looking at it in a different way. I agree. You're saying if the h is actually negative 2, a neg 2 is a plus 2.
Yeah, so
Yep.
you should have written the plus.
I agree. Don't get confused by that.
So that's wrong?
No. We've been through this a couple times, and I'm going to take you on again and show you a couple more things. What I want you to really be able to do is kind of take this back to zero product property. Set it equal to 0 and get your solutions. We know how to do this. Plus 2, x minus 2, x minus 2. You're going to get a double root down here. And so that we'll show you on the gizmo now. If I can clean this up. If I can do it without cleaning it up, I think, but I'll just try it anyway. One more time. Now he's acting
Do
up.
IQ test.
Yeah, he's acting up. Okay, you can see it anyway. If we take the slider bar, it's easier to do it over here or change the value. If I change that h value to 2, h minus 2, which way is it going to shift?
Right.
It goes to the right. So if you plot hx minus 2 squared, it did in fact shift to the right. The curvature is the same as a squared function. We didn't change the coefficient in front. What do you think happens
It's a plus.
if we take the a value? Joe, okay? If we take the a value and make it bigger and bigger and bigger, more positive, what happens to the curve? Y equals x squared. If you put a 2 or a 4 or a 6 or an 8 or a 10 in front of it, what does it do? Wider is this way. Steeper is this way. If you put big coefficients in front of that, you're multiplying y, so it's going to go steeper. We'll play with the gizmo in just a second. Okay? And if you can take as a fraction in the front, we'll flip it in a second. If you go fractional, which is what your satellite receivers do, we talked about this at home in terms of science. A dish receiver at your home has a fractional coefficient mathematically in front of it because it wants to receive that light energy, right? The microwave energy in this case. What if I make the a negative?
Goes down.
Yeah, that doesn't surprise you at all. You know what? Let's do. Let's go take the gizmo together because this one's a little bit tricky to do. My circle erase is getting kind of weird on me. Try the circle erase one more time. Thank you. All right, let's go take the gizmo together, and then I'll get you to the learning assignment. Okay, here we go. Number 1. I'll give you guys a head start. several different skills are going to come out here. Number one, which of the following four graphs is half x squared? A, B, C, or D? Have an idea, have an argument. A, B, C, D. And can you help yourself out? Can you eliminate any of the possibilities? Jackie, ideas? Can you eliminate anybody up here? A, B, C, or D?
B and C.
Why can you eliminate B and C? Great insight. That's an opening down problem screen. It has to be a neg x squared. That is not a neg x squared. That, of course, is a great standardized test strategy, SAT type strategy. Eliminate the possibilities. You're down to 2 already. Now you've got a difference in those graphs. You want to figure out how to match it up.
Y-intercept.
The y-intercept
Plug it
is what in this one, and it's what in this one. Which one's correct?
A.
Why do you think A is correct?
Because there's not a number, like there's no number, so it's like plus 0.
That's a great insight. You can make this equation, Mr. Green, half x squared plus 0. And so what you've said is, if the vertex is h comma k, and your basic equation, of course, is that one. Joe is saying the k value is actually, yeah. What's the k value here?
2.
Right. Good job. So if you had your Max open today, you were doing your gizmo at this point, you would, of course, think you're saying A. And I suspect that you are correct. Number 2. I think we got enough workroom here. Let's go down to number 2. Okay. Let's see if the circle of the race is going to work this time. All right. Number 2. Yeah. This guy? Is that bothering you, June? Okay. Oh, do we have more? Oh.
If
Oh.
red dots too.
Yeah, is anybody else?
I
And these guys over here?
And there's also
I don't
green
know.
down.
Oh, you guys are beginning to waste time. Where?
It's here.
Oh, for heaven's sakes.
Oh, there's also
It also.
No more!
Okay, fine.
All right. Number 2. You know your base vertex form now. A parens x minus h squared plus k. The h corresponds to which characteristic of the graph? This guy in here we've been playing with. The h has to do with which one? Maybe eliminate a couple. The h has to do with who? Can you eliminate one?
B.
B. Why can you eliminate B? There's actually an interesting discussion on this one. Let's talk about B. B has to do with the coordinate of the x-intercept. Think about that a second. Are those x-intercepts? What do you think about B? You're stumped. You're not usually stumped. There's 2. Interesting point. I thought parabolas almost always, unless you have a perfect square like we did a minute ago, that's called a double root, right? I thought they normally had 2 x-intercepts. What does B infer? If you read the English of that, infers there's only one intercept. Are y'all with that? If you look at the way this is worded, the x-coordinate of, the x-coordinate of the x-intercept, well, intercept is singular or plural? It's singular, so that's 1. That does make you think, actually. Very good point. Let me ask you these 2 questions. Does h have anything to do with the y-coordinate of the vertex? Does h correspond to the y-coordinate?
No.
No. Who is the y-coordinate? Very good. And. And.
It's B is also not.
B is not correct because they're limiting it to a single x-intercept. Is h, by definition, the x-coordinate of the vertex?
Yes.
Exactly. Because, by definition, we want you getting comfortable with this idea today that the vertex is hk. You okay with that? First time, I know. But when you're in Algebra 2 doing this kind of Algebra 2 work, by definition, hk is the vertex. Next one. All right, June, trying to make you happy with the dots here. No dots. How about dots?
One.
Oh, I got one red one. Where is it?
It's on the side of the pole.
Oh, for heaven's sakes, parents. All right, number 3. Okay, ready now? Ash.
I thought the acronym was the negative of the
It's going to literally be HK. Let me talk through this right now. Who can read the X? Who can read the vertex out of that pole? By definition, this is what you're using. What's the vertex of this parabola? June.
-4, -5.
Bingo. Now, June just said it's -4, -5. An ALS 2 teacher would walk in and more than likely tell you this. Quit trying to go through the 15-minute explanation, and I want you guys to set this equal to 0. Because that's when intercepts happen. Intercepts happen when you set it equal to 0, zero product property. What are you going to get out of that? You're going to get -4. That's why. That's the shortcut. Okay. And somebody said, I think somebody said this, you take the opposite sign. Benji was talking about the opposite sign. That's true. How about this one? There's a +3 right there. What's the vertex here?
4, -3.
That's a +3, sorry.
1, 3,
4, comma,
3, 3.
This is literally just the vertical shift. It's a +3. We're going to see this more in just a second. All right, let's go. Question. Compare, please, this graph with 3x squared. So there's nothing on the inside of that parentheses relative to the h here, but you do have 3 parens x minus 4 squared. How does it compare to 3x squared? Is this one steeper, more? Is it less steep, more steep, shifted to the right, or both B and C?
Both B and C.
Albert? I did?
Oh, it's not shifted to the right.
Albert? So take a look, guys. One at a time. What's true about the steepness of these two graphs? They're both 3. So, is that true? Is that true? They're both 3 coefficients in the front. That's the steepness or the wideness. Is this, here we go again, the confusing part about today. Is this guy shifted to the right 4 from your buddy over here? In other words, look at it compared to this. Is that a right shift 4?
Yeah.
Yeah.
It is. Remember, set this equal to 0 and solve x equals 4. Take the opposite sign, x equals 4. I think you would have knocked off C. The next 2 are pretty good ones, especially the last one. I really like the last one. It really has us think. Okay? Try one more time. You guys aren't normally so picky about my little straight marks.
There's a dot on the correspond.
Okay, number 4. I only had 2 more, guys. 2 more, and then grapher, and then I'll give you a break. We'll move on. Number 4. You got 4 functions. Which one has a max of 2? Now think about what they just said. It's got a max of 2. Who have we not called on much today? Nick. You got ideas on this one, Nick?
B.
B. I have a vote already. Leo, got an idea on this one? A max value of 2. Well, can you guys tell me one quick thing about a max value? If you're dealing with parabolas, how are you ever going to get a max value?
If it's a vertex opens down.
If it opens down.
Oh yeah.
See it? Good, June. If you know parabola, we're not going to study these guys this year. You'll do these in ALS 2 where you'll square the y. We're studying these guys right here, right now. They're all going to do this.
Are they different?
Yes, they go side. These guys go sideways. We'll do that later. Wait a minute now. A parabola that we're doing this year looks like these. Which one's going to have a max value, left or right? A max value,
Right.
for sure. In fact, let's talk about weirdo real quickly. What is the maximum value of that curve? It's infinity. It isn't even a value, right? Does it just go up forever? All right, so does the maximum value mean it opens down?
So it's C.
What's that mean to your answers?
C.
Well, it could be C or D if you want to argue about it, right?
The Yankees.
Are these gone? Positive values. Nick, why are you thinking it's C, dude?
Because there's a 2 behind.
Nick is looking at that as the Y value, that's the K. That's going to have a maximum value of 2. Bingo. All right. Last one. It's a good one. Okay. Last one. There we go. It is a table of values. And I'm going to ask you to do something with your brain. I'll give you a head start. Nothing but a table of values. And it is a quadratic. They're not going to play with you here. It's a quadratic. X, Y, yeah, I see that. They're asking you the behavior of this parabola. Does this guy open down? It's got no x-intercepts. Opens down, it's got 2, blah, blah, blah. I want to give you guys 20 seconds to look at it, look at the data, and give me a couple of insights. Look at the data, and I want to see maybe who's looking at something visually here. I'm not doing paper stuff right now, this is just more like mental. Look at the data, what do you see in the data? What's the parabola? How's the parabola behave? Any initial thoughts? What are you seeing? I know a couple people who got some ideas. I can give you a little help, and I will in a second. Ideas. Ashley, go. Oh, you're giving me an answer. What do you think it is? B or C? C. But help me out. I don't know the answer. I want to understand what's going on here. What do you see in the data, you guys? What's it saying to you? You're getting 2 what?
2x.
How'd you get 2 x-intercepts? Interesting. X-intercepts happen when?
And y is at 0.
Oh! Okay, that's a cool insight. Are the 2 x-intercepts right there? That's one really good point. But I want you guys to tell me if you think this parabola opens up or down and why. Why does it open up, Connie? So you think you're totally on the right track. Did Connie or anybody else think about graphing it in their head?
Yeah, it's going down.
Perfect. Connie says, look, it's going -5, -4, blah, blah, up to 6, 7. Look at the Y values. What are they doing? They're going down.
And then the
Great.
increase.
Great job. And they're going down, and they go down to -4, and then they go back up. Oh, great point. Not a very pretty parabola there, sorry. But it definitely opens up. That's great. I want you guys to be able to see a table of values. Looks confusing, and look at the behavior of it. Instead of vertically, graph it horizontally. That's a really good job. So, I'm sorry, what were their questions here? Oh, does it open down?
No.
Ah! Ha! How many intercepts has it got?
2, so it's D.
It has got 1 x-intercept. No, it does not. You all figured that out. It's a very good job. That's a very good job. Really well done, you guys. A little bit hard on this today. I know the H thing's confusing, but y'all hung in there really, really well. One more thing to show you. Wayne, go.
Oh, is there like a reason why is it H and K?
Nomenclature. It's like y is an mx plus b. No.
All the Hong Kong people are really good at math.
All right, one more thing.
Oh, sorry.
And Mr. Hendricks is videoing for us here. You guys, I know that we've gone a longer time than normal. Normally you get a break by now. Let me just show you the grapher real quickly, and Mr. Hendricks can be finished with us, and we can move on. And again, I'm going to do this together with you. True or false, you've seen grapher before.
Yeah.
All right. True or false, it kind of looks like that. Yeah, and we use the 2D for default. Okay. Let's graph the basic parabola. What is your basic parabola? X squared. How do you do squared?
Like the
Good job. Caret key, shift 6, enter the 2 that give you the squared. Now if you'll notice the cursor up there, you guys, is the cursor still in the exponent position? How do you get it out?
down.
Down or right arrow. Right arrow works really well, so you're down. If you graph this, and you know I tell you to always see it first, what's it look like? Parabola, what's the vertex?
Zero.
Bingo. All right, cool. Yeah, that should not surprise you at all. Now, tonight on your learning assignment, we're going to ask you to graph these and screenshot them, save your screenshots, and you're done. Let's compare this, for example, to this one. Two ways to enter a new equation. You got equation, new, right? And then you have down here at the lower left the plus. So let's go put a new one in here. Let's put in here, I'll give you kind of, you want a hard one or a medium hard one?
Hard one.
Hard one. Okay, here we go. I'm going to make it that, that, that. I know. Change the number. Okay. Before I press enter, let's do the work that we can then make sure our machine gets it right. What's the negative going to do?
Make it
Down.
Open down. What's the half do?
Wide.
Wider. If it were a 5, it'd be...
Steeper.
Here we go. What's the plus 3 do?
Negative. That moves it over.
Which way?
That way.
Nice. It goes left 3. And this is going to make the vertex
-2.
It's gonna make the y-intercept shift down.
shift down. So this guy, your fundamental x squared, he ought to open down. He ought to be wider. And his vertex, can you read it for me? What should his vertex be? Beautiful. So are we thinking that it should be like somewhere over here, -3, -2, and it should open down kind of wide? Is that what you guys are arguing? Let's go find out. And I can zoom this so we can play with Zoom 1 second. Just a second. Ask me to do this real quick. Are you ready for this incredible display? Let's find out how we did. Ooh!
We did pretty well.
Not bad, huh? Even Mr. Green's ugly graph. Okay, so tonight you're going to do these. You're going to talk about shifts. In fact, can anybody tell me who have we not called on? How about Sarah? How many shifts are there in here from your friend? How many shifts did you just do to this guy to get there? Number of shifts, number of transformations. 1. Sarah, how many did you get? 3? 4? How many are there? Sarah, your first one is the negative. The second one is the half. The third one is the -3 shift, right? Left 3, and the fourth one is
-2.
good job, down 2. Okay. I think we have what we need for now. We're in great shape. Actually, your question, Mr. Henderson, pretty much done. Actually, question.
Is the x-intercept of the vertex the x that's in the parentheses, or is it the h?
Now, I thought I heard you say x-intercept.
No. Is the vertex?
Yes, ma'am.
Is the x coordinate of the vertex the h, or is it actually the x? That's
It is the
beside it?
h. You said it exactly right. It is the h because it's just a form, right? The vertex by definition, and we'll show you how to do this with complete the square. Well, whatever that number is in there, x minus h, and we'll come back to Benji's point about the minus in a second. That x minus is the x squared of the vertex. So, when I gave you this guy right here, this is Benji's point. If they give you an x plus 3, what value did they put in there for h to give you that? -3. Bingo.
So what does the x do?
The x, of course, is like gives you a two-dimensional plane graph. Mx plus b. What does the x do? It just gives you points of x, y, right? Same thing here. This just gives you points of x, y on your curve. These are nothing but points on a curve. It just gives you a two-dimensional plane graph. All right? So what I would suggest we do, guys, take a break, come back, and we'll finish up. Good job.